So this is the factorial analysis of variance part 2 video quiz. So let's go ahead and begin with what we ended with last time. So last time we taught you how to calculate the main effects and the interactions for a factorial analysis of variance. So remember, the main effects are each of the independent variables. Those are the factors. Each of the factors by themselves. And the interaction is the interaction between the two factors, or however many factors you have, to figure out how they affect each other. So for example, when we look for the main effects, we're looking at the marginal means. So on campus compared to off campus, 2.5 compared to 375. We have a separate main effect for the other factor, which is car, 2.5 compared to 375. Yes compared to no. All right? The simple effects are inside here when we look at each of the possible groups. So what we haven't talked about yet is what to do with the hypothesis. But before we get into that, let's go ahead and ask a question. Which of the following is true? So all of these are true. All of these are true. Remember, the analysis of variance is going to give you each one of these, the main effect, each of the main effects, and the interaction, as long as you tell it to, right? And all of these are true. That means that there could be a combination of things that are significant and things that are not significant, depending on what's going on. So here's what we're going to do. I'm going to go straight to the data. And what we're going to do is we're going to talk about how to test your hypothesis, how to look at your hypothesis using the factorial analysis of variance when they are significant and when they're not significant, because that's important. So let's go ahead and go to RStudio right now. Okay, let's go ahead and look at some of the data that we looked at in the last video that you worked with. So this is the one that has the information for whether you're in a relationship, not in a relationship single, or it's complicated. You're a dumper, a dumpee, and your attachment style right here. So let's go ahead and look at our hypothesis and see what we can have for our possible hypothesis. So my hypothesis is that people who were a dump E but are secure have more satisfaction than people who are dumpies who are insecure, or anyone who is a dumper. All right? So if you follow me, what I'm saying is that there's 4 separate groups because last breakup is separated into dumper or dumpee. So that would be the main effect, dumper compared to dumpee. Attachment, which is insecure or secure, so that'd be the main effect for attachment. But then the interaction is dumpers who are insecure compared to dumpers who are secure compared to dumpies who are insecure compared to dumpies who are secure, the 4 groups. Okay, so let's go ahead and take a look at that particular hypothesis. In order to do this, we have to create a model. I'm going to name my model after cereal today. So this one's called checks. And checks is going to be analysis of variance and the dependent variable satisfaction. And it's going to be separated by last breakup, which is whether you're the dumper or the dumpee. Remember, that is the main effect for last breakup, plus the main effect for attachment, plus the interaction, which is last breakup by attachment. Okay? That gives us the analysis of variance just like last time. Then when I get the summary of checks, here's what I get. So let's make sure you can see this. What you see, come on. What you see, unfortunately, isn't fitting in my whole screen because these are long. But this right here, this line right here is the main effect for the last breakup. It's just looking at the dumpers compared to the dumpies in their satisfaction. And what it says this is the p-value because it's going on the next line just because it ran out of space. It is significantly different. There's a significant difference between dumpers and dumpees. This is the main effect for attachment. Now it ran out of room, so it went on the second line as well. And that means there's a significant difference between people who are secure and insecure as to how satisfied they are in the relationship. And this is the interaction. And this is the p-value right here. It's saying that there's a significant difference between at least two of those simple effects. That is, remember, dumpers who are secure compared to dumpers who are insecure compared to dumpees who are secure, dumpees who are insecure. Those are the four groups. There's some difference somewhere in there. I'm just not sure where it is. Now, if you remember, my hypothesis is that dumpees who are secure are going to be significantly more satisfied in their relationship. Now, I cannot see this based off of these results. All I know is that there's a difference somewhere, and I don't know where it is. I do not know where it is. Okay, so here's what we're going to do. We are going to start looking at the means to figure out what's going on. So let's look at the main effects first. The main effect, if you remember, looks at the marginal means. The marginal means just looks at, we're going to split last breakup in half, right? We're going to look at the dumpers compared to the dumpees. We're not going to split it at all based off of the insecure and secure. We're not going to mess with that. The main effect is just the effect of last breakup, just the effect of dumpers compared to dumpees. So let's try that right now. I'm just going to look at the means first. T apply. And in this case, you put the last name, the dependent variable first, which is satisfaction. Okay, followed by a comma, and the independent variable, which is last breakup. Followed by what you want, and I want the mean. When you do that, here's what we get. It's saying that people who are dumpees have a satisfaction of 8.92, roughly, compared to the dumpers have a satisfaction of 4.08. Now, we do not need to run a pairwise test here because there's only two variables. And guess what? There's only two categories, levels. They're not two variables. They're two levels, dumpee versus dumper. And we already know right here that there's a significant difference between those two. That means there's a significant difference between dumpees and dumpers. And so the main effect of last breakup is significant in that dumpees are significantly more satisfied with the relationship than dumpers. Now we'll do the same thing with the other main effect, which is attachment style. And this is going to look at just satisfaction split by attachment, meaning we're going to compare the insecure to the secure. We're not going to mess with whether or not you are a dumper or a dumpee here. The main effect is just the one factor by itself, just attachment by itself. And here's what we find out. People who are secure are significantly more satisfied than people who are insecure. We don't have to run a pairwise test because this is saying there's a difference. And since we only have two levels, we know that there's a difference. And there it is. That's the difference. Secure is greater than insecure. Now, when we get to the interaction, that's when things get a little bit more complicated. Of the interaction, we do a T apply. But now we are going to look at satisfaction separated by the interaction, as I'm writing the word interaction, and in parentheses, going to put the two factors that are part of the interaction, which are last breakup, comma, attachment. When I do this, and then I put a comma, mean, it's going to give me the mean of satisfaction for each of these. So here we go. Dumpees who are insecure, their satisfaction is a 4.33. Dumpers who are insecure, it's 4.0. Dumpees who are secure, 3.50. Dumpers who are secure is 4.16. Now, here's the issue. Here is the issue. I know that there is a significant difference somewhere in here, remember, my interaction was significant. So I know there's a difference between at least two of these. One of the simple effects is significant, but I don't know if it's 13.5 compared to 4 or 13.5 compared to 4.1. I don't know. They all might be significantly different, or only one of them might be significantly different. I do not know. That is why you have to run a pairwise test. So let's go ahead and do a pairwise t-test for these interactions. Pairwise t-test, just like we did for the one-way analysis of variance, but now we're going to do it for the interaction. Satisfaction is going to be our dependent variable, and then we're going to put in, just like we did before, interaction, last breakup, attachment, but instead of putting mean now, we're going to put our p-adjust method, p.adjust method, and remember the p-adjust method that we've been using is in parentheses Bonferroni, and let's see what happens. This is now giving us the p-values of each of the comparisons. These are the p-values. So when we compare dumpies who are insecure to dumpers who are insecure, the p-value of that t-test is 1. There's no significant difference. However, dumpies who are secure compared to dumpies who are insecure, this is the p-value. Dumpies who are secure compared to dumpers who are insecure, there's the p-value. Dumpers who are secure compared to dumpies who are secure, there's the p-value. So what we're saying is that dumpies who are secure are significantly different from everybody else who is not different from each other. So when you look at these means, what we're saying is 13.5, this one, dumpies who are secure, is significantly different from each of these other groups, but none of these other groups, dumpies who are insecure compared to dumpies who are secure, or dumpies who are insecure compared to dumpers who are insecure, or dumpers who are insecure compared to dumpers who are secure, none of those is significantly different. Right? That's what that is saying. Remember, my hypothesis was that dumpies who are secure would have significantly more satisfaction, and that's exactly what we found. So my hypothesis is supported. Now, what I'm saying here is that in the future, I'm going to start asking, is my hypothesis supported? That is different from should you reject the null hypothesis? Because if my hypothesis was that dumpers who are secure would have significantly higher satisfaction, I would have found a significant main effect for last breakup, a significant main effect for attachment, and a significant interaction, but my hypothesis would not be supported because it's not dumpers who are secure who have the highest satisfaction, it's dumpies who are secure who have the highest satisfaction. Okay, so let's go ahead and try this with a new set of data. Let's try this with a new set of data. And I want to go through all of these, and we'll ask several questions about my hypothesis. So I'm going to attach a different data set. This is going to be ANOVA example class. Let me make sure that that's the right one. All right, ANOVA example class. I'm going to attach that one. Okay. By the way, if you see an error that gives you a mask that says like participant, that's just saying we're not going to, you can't use the old participant variable, right? If it's participant that's getting masked, it's not a big deal. If it's other stuff, it is a big deal. Should have detached my old one. I didn't do it, but in this case, it's not going to hurt anything. If you remember, this is some data that we looked at before, where I have whether you wear glasses, contacts, or none, your employment status, student or working, your education status, high school diploma or no diploma, and then I have sleep and screen time over here. Okay? So here's what I think. I have a hypothesis that students with a high school diploma watch significantly more screen time than anybody else. That means students without a high school diploma or workers with or without a high school diploma. So follow me on that. That's my hypothesis. My hypothesis is that students with a high school diploma watch significantly more screen time than any of the other 4 groups. Okay? Try it out on your own and let's see what we got. All right, here we go. Let's try it with a new analysis of variance. So I'm using serial. This one's going to be called, now I'm thinking about cereal. I'm excited. So let's call this one Cheerio. Okay. So Cheerio is going to be a model which is an analysis of variance with screen time as a dependent variable divided by, that's the tilde right there, one main effect for employment, right? So I'm going to test whether or not students or workers watch more screen time. But I also want plus education, whether or not you have a high school diploma, plus the interaction between employment and education, which is employment by, and I use a colon for this, education. All right? And when I do this, this is what I'm going to get. Let's pull this up. I want the summary of Cheerio. Awesome. Let's see what we got. Sweet. Great. These are all on the same line now because I used shorter variables. That's why. So this is the main effect for employment. It's comparing people who are working compared to those who are students, and there's a significant difference. This one's comparing education. It's looking at people who have a high school diploma compared to those who don't, and there is a significant difference, right? So look at these P's are much less than 0.05. Employment by education, again, there's a significant interaction there. Okay? So we know there's a significant difference. Now remember, my hypothesis was that students who have a high school diploma watch significantly more screen time than everybody else. Let's see if that hypothesis is supported. If none of these, if that interaction was not significant, then I already would know that it's not supported because there's no interaction, right? I can't separate it out. But right now, I don't know. It might be supported, it might not. Let's find out. So here's what I'm gonna do. Let's go ahead and look at the main effects first. Now, we'll get the T apply. In this case, we're looking at screen time. Screen time separated by employment. This is going to compare students to workers. And when we do that, we get people who are working watch significantly more screen time than people who are students. Now, how come I didn't have to do a post-hoc test or a pairwise test for this? Well, because I already know there's a significant difference. It's right here. Okay, there's a significant difference between those groups. Well, I only have two groups, so I know that the difference must be between these two. That's not looking good for our hypothesis, but it's not telling us that we're absolutely wrong yet. Let's look at the other main effect. Screen time divided by education. And tell me the mean. And when we do that, here's what we get. People with no diploma are watching significantly more screen time than people with a diploma. How come I didn't have to write a pairwise test? Because there was only two groups in the education level, and those are significantly different from each other, and so I know that high school is definitely different than no diploma. Not looking good for our hypothesis, but we're not sure yet. Let's look at the interaction. T apply, look at the means, and then we'll look at the pairwise test. T apply, screen time, comma, interaction. And what's in my interaction? Education. Let's keep them in the same order just to, so we don't, employment first, technically doesn't matter. And education, and I want you to tell me the mean. When I do that, here's what I get. People who are working with no diploma watch 20.67 hours of screen time. People who are working with a high school diploma, they'd watch 4.67 hours of screen time. Students with a high school diploma watch 4.83 hours of screen time. Students with no diploma, 3.67 hours of screen time. So already looking at the means, I know that my hypothesis is not supported because my hypothesis was that students with a high school diploma would watch significantly more. That can't be possible because people who are working with no diploma have to watch more. We don't know which means are significantly different from the others, though. That's when we run the pairwise t-test. And we're going to do it just like we did that t-apply. Screen time is the dependent variable, followed by the interaction between employment, comma, education. And then after that comma now, we need the p.adjust method equals, in parentheses, Bonferroni, just like that. And here's what we get. This is telling us the p-values of each of the simple effects. It's saying that when you look at, it's going to give us a lot because it's a long one. The p-value of students with a high school diploma compared to working with high school diploma, there's no difference like at all. Students with no diploma compared to students with a high school diploma, no difference. Working with no diploma and students with a high school diploma, there is a difference right there. Students with no diploma compared to working a high school diploma, no difference. Working with no diploma compared to working with a high school diploma, yeah, there is a difference. Basically, we're seeing that working with no diploma is significantly different than everyone else, but nobody else is significantly different from each other. That means that working with no diploma right here is significantly different from everyone else. We can see that in the p-values of each of these t-tests that this gave us in the pairwise t-test. Whereas none of these other comparisons is significant. Right? 4.3 is not different from 4.67. 3.67 is not different from 4.83, etc. Let's do one more example. One more example. We'll still use this particular data set, so let me show it to you one more time, just so that we are looking at the same thing. So let's go ahead and look at how your eyewear is going to affect your screen time, right? Because, you know, it's kind of a hassle to take off your glasses and all that stuff, etc. So I think that what your eyewear compared to your education. So in this case, eyewear has glasses, contacts, and none, 3 levels, and education has 2 levels, which is high school diploma and no diploma. So this is a 3 by 2 on screen time as my dependent variable. Let's try it out. And we're doing serial this time. We're gonna do I'll just call it Cap'n for Cap'n Crunch. Cap'n is my model, and it is going to be an analysis of variance of screen time separated by eyewear. This is the main effect for eyewear plus the main effect for education plus the interaction of eyewear by education. And when you do that, you get nothing. So we got the summary of Cap'n. And when I do this, this is what I get. Let's show you the results so you can see it. All right, look right here. This is saying that when we're looking at screen time as a dependent variable, there's a significant difference between people who have the different kinds of eyewear, right? There's also a significant difference between people who have different kinds of education. There's also a significant difference in our interaction. Now remember, my hypothesis is that people who wear glasses watch significantly less screen time than everyone else. I think that's what I said before. Anyway, that's what I'm saying now. People who wear glasses watch significantly less screen time than everybody else. Okay? And not only do I think that people who wear glasses watch significantly less, but I think it depends on your education level. People who wear glasses and have no diploma, I think they watch significantly less than everybody else. That's what I think. So in order to do this, let's go ahead and get the means. We'll do the t-apply, screen time. And this time we're going to separate screen time by eyewear. We're going to look at the people who wear glasses compared to the ones who wear contacts compared to the ones who wear none and get the mean. Now, when I do this, we already know there's a significant difference between those groups. However, we do not know where it is. In this particular case, we know there's a significant difference, right? That p-value is less than 0.05. All that tells us is there's a difference somewhere, okay? This is as if it had run it like a one-way ANOVA. And we don't know where the difference is because there's more than two groups. If there's only two groups, then you know, but there's more than two groups. So that means we need to run a pairwise t-test. Remember, I had hypothesized that people who wear glasses watch significantly less. By the way, I already know that that's not true because look, screen time is the highest right here. So I just look at the means and know that that's not the case. But let's see what the differences really are. Pairwise t-test screen time separated by eyewear. And then I need the p-adjust method. P.adjust method is going to be, in parentheses, Bonferroni. And here's what I get. These are the p-values of the different groups. There's a significant difference between people who wear glasses and people who wear none. This is the p-value, 0.036. However, there's no significant difference between people who wear glasses and contacts, and there's no significant difference between none and contacts. So what that means is that there only is a difference between glasses and none. All right? There's these 8.125 is not significantly different from 13.125, and 8.125 is not significantly different from 4.125. Okay? That's what we see. So that is the main effect for eyewear in this particular model. Now, let's look at the main effect for education. T-apply, let me just make sure. Yeah, it is education. I want to make sure that I was doing the right one. Screen time, now separated by education. And when I ask for the mean, here's what I get. People with no diploma are watching significantly more than people with a high school diploma. I do not have to do a pairwise test though, because look right here, this is significantly different, and there's only two levels. You either have a diploma or you don't. And I know there's a significant difference there. Therefore, people with no diploma have to be watching more screen time than everybody else. Now, it's already pretty clear that my hypothesis is not going to be supported, even though these are all significant, even though the analysis of variance has two significant main effects and a significant interaction. It's probably pretty unlikely that people who wear glasses watch significantly less. People who wear glasses with a high school diploma, with no diploma, watch significantly less than everybody else, right? That was my original hypothesis. That's not going to be supported. We're pretty sure about that. Let's look at the means. T-apply, screen time. This is going to give us the means of the interaction between eyewear, comma, education. And I want the mean of that one. And here's what I get. Here's all the different groups. Glasses with no diploma. Ooh, wait a minute. Look at that. They are watching a lot of screen time. Wait a minute. Maybe my hypothesis is going to be supported. Let's find out. These are all the means. So I know there's a difference somewhere in there. The analysis of variance says there's a difference somewhere. It's a pretty good guess that the lowest and the highest are significantly different. But let's find out if glasses with no diploma really is the highest screen time compared to it's the lowest screen time is what I thought it was going to be. That wasn't it. So obviously that's not going to be the case. Maybe it's the highest instead. So in this case, we're going to do the pairwise t-test with screen time as the dependent variable. Screen time as a dependent variable. And I want the interaction between eyewear, comma, education, followed by p.adjust. I want the p-adjust method. Come on. Adjust method equals, and in parentheses, Bonferroni. When you do that, here's what we get. Here's our different groups. There's a lot of these because just they're running out of room here. Okay, if we want to compare people who wear contacts who have a high school diploma, these are all the comparisons. The only significant difference is people who have glasses with no diploma. Okay, so the only significant difference is people who wear contacts with a high school diploma is people who wear glasses with no diploma. Let's look right here. The same thing is happening with people who wear glasses who do have a high school diploma. The only significant difference is people with glasses with no diploma. Glasses with no diploma, right there, compared to neither contacts nor glasses high school diploma. Glasses with no diploma is the only significant difference. And right here, glasses with no diploma compared to contacts with no diploma is the only significant difference there. And then finally, glasses with no diploma compared to none with no diploma, that's a significant difference. Now, if you had just looked at this pairwise t-test, you would have thought that the hypothesis could be correct. But remember, I was initially predicting that people with glasses and no diploma would watch significantly less screen time. In reality, when you look at the mean, they watch significantly more screen time than everybody else. So make sure that you are looking at the mean and looking at the appropriate tests to figure out whether or not the hypothesis is or is not supported. All right, thanks everybody.